So finally, let's talk about our work. So the idea here is to use this strategy to calibrating question-answer systems, and we will try to do this with quantum neural networks. Calibrating question-answer is important because, in general, depends of your algorithm, the answer is not well calibrated. What it means? Sometimes your algorithm said that if you are driving a self-driving car, they could say, okay, you can go, but in fact they commit a mistake. Oh my God, this is a mistake, you should stop it. So it's a problem. So it's need to calibrate the answer to check if it's underestimated or overestimated. And they use another machine learning just to calibrate your answer. And for question-answer systems, it's quite important. Well, there is some algorithms to do question-answer systems. The BERT algorithm is probably the most famous. It was developed by the Google team, and probably you never hear it, but you use it all the time. If you go in the Google and make a question, it gives you a suggested answer. This is BERT working. When you try to write an email and they suggest a word for you, this is a BERT algorithm also work. When you receive an email and there's that suggested answers, this is BERT algorithm working. So they developed this in 2018, and everybody nowadays use it. It's developed by the Google AI team. So it's a really breakthrough in the area. They use, for example, 340 million parameters to train this algorithm. They use the full internet to calibrate these algorithms. Not the Wikipedia, but they use books, all the sites, everything, just to calibrate this pre-training. And once you train, then you have these 340 million parameters determined, then you just use it to make new suggestions. For short, this is an unsupervised learning, so you don't need a human to check it. And this works something like this. They just take a text and they remove some words, and they ask for the algorithm to try to predict what's the word that is missing. And then they, of course, that in the beginning they don't reach a good success, but when you use millions and millions of texts, then they begin to determine what's the right answer, what the right word that you put to complete your sentence. There's some other new ones. There's the NVIDIA right now. It's 8 billions of parameters. And here there is from the Facebook, that's a Roberta. Roberta is a change in the BERT. It's an upgrade. They just use a little bit more than parameters. And there is this Tilbert that we use in our work. That's a simple algorithm to BERT. Even to use BERT is quite difficult because 240 million parameters, even pre-trained, it's quite complicated to reading your memory and to work. So this is important. The Roberta, that was developed by the Facebook AI research, now Meta AI research, University of Washington also. So they introduced the Roberta, and the Hugging Face, the AI community, just developed this Tilbert. That's a smaller, faster, cheaper, and lighter version of the BERT. This is the two algorithms that we use in our work. The idea is to take the answer suggested by the Roberta and the Tilbert, and then to calibrate the answer to get the right one, or at least the right probability to be the right answer about your question, over your question. Okay, so calibration of machine learning models is quite important because, as I said, sometimes you have crucial answers, and if you commit a mistake, you can kill some persons. Yes?
How can you compute the cost function when you don't know a word?
They just put some notes for some score for each word. So there's a set of scores that they are distinct. So a number for each word in the dictionary. Okay, this is a kind of uncalibrated, for example, machine learning. So the idea here is that your algorithm said that the answer has 20% of be right, but when you check with different data sets, you see that's not 20, but it's 15. Here you said that it's 60, but when you check, it's not 60, it's 50%. So this is an overestimated calibration. Yeah? So this is the problem. The idea is that you reach this in the middle, because then when you say that's 40, in fact it's 40. When you say that's 80, in fact it's 80. This is the idea to calibrate a machine learning problem. So we use the Squad 2 dataset. This is a dataset that you find in the internet. It's just a dataset with question and answering. And this is an uncalibrated one when you use the Stubert and the Roberta. I'm sorry. For the Stubert, you use the Squad 2. And for the Roberta, you use an internal entity dataset. So you see that Roberta for the entity dataset is quite uncalibrated. And here also, this expectation calibrated error it's large enough. So you have a problem here because they said that you have here underestimated, here overestimated. So the idea is to try to correct this. So you just include your answer in the Stubert or Roberta. They give you an answer. And then you take some features of this answer. And then you include in another machine learning, in our case, a quantum machine learning algorithm, to try to calibrate these answers, these probabilities. This is the idea. What about the features? So the features are just 5 features that you need to calibrate. So this is why we can use in a quantum computer, because each feature can be coded in 1 qubit. And the features that we use to calibrate it is the beginning of answer span score. This is a feature that Roberta and the algorithm gives for you. All of them the algorithm gives for you. The end of answer span score. This is the value that I said that they have, a score for each word. The number of words in question, number of words in answer, and also there's a probability there is no answer in your test, in your paragraph. This is the idea. The point is that you have a question, then you take a paragraph and try to find the answer inside this paragraph, and sometimes the answer is not there, so there is a probability the answer is not there. This is the 5 features that you use to calibrate it. So, yeah?
When you mentioned quantum machine learning, and now you're mentioning quantum neural networks, is it the same thing?
Yeah, it's a kind of quantum machine learning algorithm. There's more than this, but this is one of the quantum machine learning algorithms. Okay? It's because machine learning, there is more than neural networks. Neural networks is a kind of machine learning algorithm. Okay, so we use this algorithm to do our task. We use full measurement, just to mention. And here is the calibrated answer. So you see that before I had something like this. And then, in the end, they just put the things in the right place. Of course, I don't increase the probability of the answers, but I can say the right probability of each answer. So it's much better than here. You see the expectation calculate error is 0.70, calibration error, and here is 15, and here it was 64. Okay, so this is for the Squad 2. If you take the NTT data, this is the calibrated one. Here is a classical calibrator. Here is a quantum calibrator. You see that the classical calibrator also do the task, but here we're showing that the quantum computers can do the same task. And in fact, here is in fact lower than this, but it's almost the same. But if you look for the Roberta answer, it's completely uncalibrated. And here we have the right answer, the calibrated answer of your algorithm. Okay? So this is our work. Just to conclude, so the NISQ area, in my point of view, will certainly be the next step in quantum computing. Given the technology nowadays, it will be quite difficult to reach millions of qubits. Creating robust qubits will be crucial for the development of functional quantum algorithms. This is my view, of course. And what we show is that variational quantum algorithms can be used to calibrate question-answer systems. Just to conclude, a bit of marketing. I'd like to talk about our computation course that we give in Unicamp. For students, you can ask for fellowships. It's working on, we are in our second term now, and if you would like to talk about it, just write me in this email. This is for beginners, but the next year we will have one for advanced that will be for variational quantum algorithms, quantum machine learning, quantum optimization for the next year. Okay, so thank you very much. That's all.